Hi, and welcome to Gaming with EaselJS, an advanced Canvas course on Tuts+. In this lesson, we're going to start creating our scrolling space shooter game. The first thing we're going to need to do is to get a hero on the screen and to start moving him. That's why this lesson will be focused on keyboard interaction with our character. Because we finished our tile-based puzzle game in the last lesson, I've started from scratch and created a simple project template for us to begin with. We have a hero class and our main class, and we have the same utilities that we had before. Open up your project in the terminal and type grunt. If you go to localhost 9001, you'll see what the project contains so far. So we have a main file that's preparing the world, which is basically just creating the stage and adding the hero to it. And the hero is pretty simple too. Now when you're thinking about keyboard interaction, your first impulse may be to set up some keyboard event listeners here in the hero's initialize function and change his X and Y position depending on if the arrow keys are pressed, for example. But I can show you why that's not a good idea quickly right now. So we've set up a simple event listener for key down, and we change the X position of the hero by 10. If I look at the result of that, when I press key down, you'll see that the hero moves a little bit, then there's a pause, and then he continues moving. This is obviously not the way we want to control our hero. This is because of the way that key events work. So we need to do something a little smarter, and we're going to create ourselves an actions service or module which will help us manage our keyboard actions. When we build a game, we don't really want to know exactly when the key down was actually initialized. What's most important to us is what state the key is in when we're processing our global tick. So really what would be nice would be some kind of module or service that we could call on during the tick event to tell us which of the keys are currently pressed. So let's go and build that now. We'll make a new file and we'll call it actions. Now we may also want to be able to listen specifically for an event when it actually happens. So our action service will not only hold the current keys being pressed, but can also be used to listen for specific game actions such as fire or move left. I'm going to use the create.js event dispatcher and the easel event in this module. Now the next thing we're going to do is create a map between key code numbers and in-game actions that we want to associate with them. By creating this map, we're essentially separating the two, meaning that we can change our controls at a later time if necessary. So we're going to set up a controls object, and 37, which is the arrow key, will mean move left, 39 will be move right, 38 is move up, and 40 is move down. Next we'll make it so that 32, which is the space bar, is the fire key. We'll also create an object which can hold the current actions, and we can design the interface of our module. So our action service will have an init function and a get function. Let's define the init function. Now while in the interface, this function is called init, I've named it actions_init here to make it easier to debug. Now our init function will need to use the create.js event dispatcher to add messaging capability to our module, and then it will need to set up some event listeners for key up and key down. We'll pass as an argument the window to which we want to listen to. So we'll call event dispatcher initialize and pass the action service itself. We set that to a variable here exactly for this reason. And we'll add our two event listeners to the window that was passed. We can even set win equal to win or window in case you want to use it without having to pass the argument. Our actions get function can simply return current actions. So what do we want to do on key down and key up? We're going to want to get an event object that holds a little more information than just the standard key down event would. There are some things we know we'll need to use quite frequently throughout our game, so we want to expose those things first and foremost in the event data. We'll also want to dispatch the event onto our action service so it can be separately listened to if required. And then in the event of key down, we want to store that key information in current actions, and in the event of key up, we want to remove it from the current actions. We'll work out our process event code in a little bit, but basically if we get a key event out of it, then we want to add that key event to the current actions. And we'll use the key event type, which should end up being our action name, as the property name. And we'll set that equal to keyEvent.data. We've passed down here into the process event function so that we can identify it over the key up events. Then on key up, we want to do a similar thing, but instead of storing the key event, we're going to delete it from the current actions. So when we process an event, what are we doing? Well, firstly, we want to create a general event out of this so that if we need to, we can continue to use our actions module instead of having to dip back to the native DOM event. If there is no general event, then it means that we can't do anything with the event we've received and we'll return. Next, we want to create our specific event. So basically it's the same, but we don't pass in an event name. We'll use the specific action that we get out of our controls object, and then we can basically dispatch the general event and the specific event onto the action service, and we'll return the specific event. So what does this prepare event function look like? That's the most important thing that we'll be using to define our events API essentially. So, like I said, our prepare event function requires the native event, the phase that we're in, up or down, and the type of event. The first thing we want to do is look in our controls object for an action name that has the key, which is the same as the event key code. So when we press a key, JavaScript will attach a key code to the event. That key code is going to correspond with these controls up here. So if we have no action name, then we don't want to prepare any events because our application doesn't care about that. If a type was set, we'll set that as the type, otherwise we'll use our action name, and we'll prepare our event data. We want to have a name in our event data, and we want to know whether the Shift key, the Meta key, or the Alt key are pressed, or the Control key, and we'll also pass in the phase. These are the most important bits of information we need. We can always add to this later if we find some other data that's important as well. Then we want to create a new Easel event that can be used by our action service. We pass in the type, which is either key or it will be the action name, and we set the data of the event to our event data that we've defined here. We'll set another property on the event called native event, which is where we'll put the original browser event, and then we'll return it. So let's go set that up in main. We'll bring it into our main file under the name of action service. We're under no obligation to keep our variable names the same as our module names. Then, when we're setting up our application, we're going to call action service.init, and we'll pass in the current window we're working in. Now that's thrown because I put action and not actions. So we've compiled everything okay in Grunt, and if I refresh, you can see there's no errors. That's great. So in our hero module, we can do the same. And now that we've initialized our actions module, anywhere that we require it, we can use it to get the pressed keys at any given time. So let's just start off by console logging actionService.get. As you can see, it's printing out an empty object. But if I start hitting some keys, like the arrow keys, you can see we've got move right. If I press up, we get move up. If I let go, we get just move up, and I can do move left. And if I hold spacebar, we'll get fire at the same time. So as you can see, I can have 3 keys down at once and there's no problem. By separating out the code that manages key actions, we're avoiding a lot of problems, such as key lock, and we're also just making our lives a lot easier by having a convenient interface for managing user interaction. So just to finish the lesson off, we can get our actions using actionService.get. Then, quite simply, we can see if there is actions.moveRight, then we'll increment our X position. And if there's actions.moveLeft, then we'll decrease our X position. So now I can move left and right. And as you can see, there's no lag between the first positional movement and the next one, as there was when we were trying to listen to key down events. Well, that's all for this lesson. In the next lesson, we're going to take full control of our hero and allow him to move around the canvas using inertia and acceleration. Ciao!